All right, ninth graders, we are looking at page 36 in your math binder. So pull this page out of your binder. It is called, What Do You Know About Inequalities? So let's start at the very top here and remind ourselves, what do each of these symbols mean? So that first symbol there, that symbol, I know you've seen that before. This one is less than. Now, some people like to remember this because they see that less than symbol and they think it looks kind of like an L. If that helps you remember it, then great, that means less than. Here's how I always like to remember it. It starts with a small pointed end and it ends with a larger opened up end. That's the less side first. This one opens up opposite. It opens with the big end. That would be greater than. So how do these next two relate to the last two, but they're slightly different? Obviously, they have this little symbol underneath, and what that symbol is, it's combining the less than and the greater than symbol with the equal sign. So this would mean less than or equal to. The other one would mean greater than or equal to. So we can be less than or equal to, and we can be greater than or equal to. And what that would mean is less than, like the number 5 is less than the number 6. And anything underneath 6 would count for being less than 6. But if I was talking about less than or equal to 6, I would still have all those numbers like 5, 4, 3, 2, 1. But 6 is also technically less than or equal to 6. So it includes that first number when you put the equal to on it. Okay, so I've got 8 scenarios here, and I want you with a pencil to decide whether or not you think that those are true or false, and kind of go with your gut reaction on them. Hopefully you can think through some of them. Some of them are going to be more difficult, so you might have to use your context clues and make your best guess on those. So pause your screen. I want you to read through these scenarios and tell whether you think they're true or false. I promise we'll change them after if you get any of them wrong. All right, pause the screen. All right, you've had a chance to look through these. Hopefully you've got your pencil in your hand still, and we are going to figure out whether or not these were true or false, and you're going to fill in an explanation for each of them. So the first one says, at least means the same thing as less than. Ninth graders, this is false. At least does not mean less than. If I were to tell you that I have at least $20 in my pocket, does that mean that I have less than $20 for sure? No. At least $20 would mean that there could be 20 bucks in my pocket. So it actually means, I'm gonna write at least means greater than or equal to. I might have said that backwards just a second ago. When I said, if I had at least $20 in my pocket, it doesn't mean I have less than $20. It means I have $20 or I could have more than $20. $20 would be the lowest amount that it could possibly be. Okay, number 2, the notation 12 is less than x means the same thing as x is less than 12. It works just like 12 equals x and x equals 12. This one is also false. The first one here says that x is on the bigger side of 12. It says 12 is less than x. So 1 says x is bigger than 12. And the other one says it's less than 12. So when it says x is less than 12 here, this top one is not the same thing. You can't just change the numbers around. If you change the numbers around, you also have to reverse that symbol in the middle. And that's a mistake that a lot of people make in 9th and 8th grade math. Number 3, the word that describes the inequality, x, that symbol 100, are x is greater than or equal to 100. True. I'm going to put a smiley face. It's just the way we say it. X equals 6 is a solution to x is greater than -3. Let's check that. X is greater than -3. Well, if I were to put 6 in there, is this true? Is 6 greater than -3? Yeah. 6 is greater than -3. That's a true statement. Okay, the solution to -2x equals 16 is x less than -8. So let's solve this thing. We know how to solve an equation. To undo -2 times x, I would divide by -2, divide by -2, and I would get x, and this side I would get -8, but there's a problem. When I divide both sides by a negative number, something fancy happens to the symbol in the middle. It reverses. So this one is false. And this is very, very, very important. I'm going to use a red star here. When you multiply or divide by a negative number, reverse the symbol. That is super important. Please don't forget to do that. Every time you're multiplying both sides of the equation by a negative number, or if you are dividing both sides of an equation by a negative number, you reverse the symbol. That means you're dividing by the negative. You're doing it on both sides. It doesn't mean that if there's just a negative in the problem at all, you reverse. It's only if you do an operation on with that negative in it. Okay. Solving 2x minus 4 is greater than 6 requires the exact same steps as solving 2x minus 4 equals 6. All right, so on this first one, we would add 4 to both sides, and then we divide by 2. When we divide by 2, that's a positive number. We don't have to reverse the symbol. On this one, we add 4 to both sides, and then we divide by 2. Yeah. Add 4. Divide by 2. Okay. This one, I can already see what they're doing here. We still add 4 to both sides, but then we're dividing by a -2. Why is this one false? We're adding 4. We divide by -2, but remember, when you divide by a negative, you flip the symbol. Reverse that symbol. We have to flip it around for the inequality. And for the equation, we didn't have to flip it around. All right, this last one. I'm sure you looked at this and thought, what? Let's talk about it. X less than 7 means the same thing as parentheses 7 comma infinity. That is actually false. And hopefully you're thinking like, oh my gosh, thank goodness, I don't want to figure out what that means. It doesn't equal 7 comma infinity. It actually equals -infinity comma 7. So I hope that makes a lot more sense. I'm kidding. I know that that probably makes absolutely no sense to you right now because we haven't talked about this yet. And that is actually a wonderful segue into our next little section here. We are going to discuss what the heck this weird thing is. Don't be freaked out. They're called intervals and interval notation. So when you are given the equation or the inequality x less than 2, you can write that in the middle. I'm going to write that in words, and I'm going to say x is less than 2. All right, so I can do that for all of these. I know that x is less than 2. Right here, I know x is greater than 2. On this next one, x is less than or equal to 2. I'll write that out, less than or equal to 2. And then the last one, x is greater than or equal to 2. Okay, so let's get a graph of these things on here. Now, I would like our graph to look like this. I want you to draw a line. And we know that we're dealing with the number 2, so I'm going to put a 2 in the center. And I know that the number surrounding 2 is 1 below and then a 3 up above. So if I were to graph this thing, it says that x is less than 2. So when we graph inequalities, we always want to shade where the solution could possibly be. So everything lower than 2 is going to be a part of our solution, but 2 itself is not part of the solution. So what you saw in the 7th grade, you draw a circle there, because you're saying we do not have a solution at 2. You cannot fill in the solution at 2, but you can fill in all the solution that is lower than 2, which is why we usually shade there. And we fill in our arrow going toward the left underneath the 2. Okay, so on this one, x was greater than 2. Well, how would that look different? If less than 2 was shaded below, greater than 2 is going to be shaded above. Now you'll notice I'm still going to do this open circle where it's not filled in. The reason I do that open circle is it's showing that the solution doesn't exist at the number 2. It just exists above the number 2. Okay, let's go to, and by the way, sometimes I get asked, why don't we just fill in 3 and above then? Well, technically there are solutions between 2 and 3, like 2.1 and 2.2 and 2.3. And you can get infinitely close to 2, but you never actually can have the exact solution at 2, according to this inequality. Okay, on the next one, it said x is less than or equal to 2. So I'll still put 2 in the center. I'll place 3 above, 1 below. And the big difference here is the fact that it's got an equal to. Since I can equal it, I am going to call that a closed circle. And I'm going to still shade everything below, just as I did in the first example. And it looks like that. So that is x is less than or equal to 2. And on this last one, got a 2, a 3, and a 1. And it is greater than or equal to 2. Since it can equal 2, I need to close that circle and make it a filled in closed circle. And everything above the 2 is shaded. You've seen all of this before. This is not new. The stuff that is a little bit new is this interval notation. And it actually directly responds with the graph. So the graph is telling you where all the solutions can be. Interval notation is also going to tell you what all the solutions can be. So do you see how this first arrow with x is less than 2, it points to the left. How far to the left is that going to keep going? The arrow means that it will never stop. So it goes to the left to 0 to -1, -2, -3, -4, -5, -6, -7, -8, -9, -10, -100, -1 million, -100 million. How far to the left could we keep going? I don't know a ton of numbers up past like the billions and trillions, and I don't know if zillions is a real number, but we do use a term to talk about really, really far, uncountably far, not quite uncountably, but infinity is that number. But it's not heading toward positive infinity. Positive infinity would go upward. It's heading toward negative infinity. So we are going to say that the lowest interval that this could do would be negative infinity. Now, can you ever actually reach infinity? No, because if you think you reach it, then just go one further and now you're at a new furthest number in the whole world. So we just call that idea infinity. Infinity is not really a number, it's an idea. But you can't ever reach it. So we are going to use what we call a soft parenthesis. It's just a regular parenthesis, I suppose. And that means that this starts, I can't reach it, but it's negative infinity. Then I put a comma and I'm going to say now how high this solution set can go. So the highest it can go is 2. It can't go to 3 because I didn't draw a circle at 3. I didn't draw any shading at 3. I ended at 2. But do you notice how that circle was not filled in? I can't actually touch the number 2 with my solutions. So I also have to have a soft, non-inclusive parenthesis there. If you're feeling like this is weird, you're right, it is kind of weird. That's why we're gonna do a couple more examples together. Okay, let's look at the next example, number 10. So this one does not begin with an arrow to the left, so it doesn't go to negative infinity. This one starts as the lowest possible point would be that 2. But remember, the 2 is not included, so I put an open parenthesis because that's an open circle there. It means I can't actually touch that number 2. And then this list is still going to tell me how high the graph can go now. The left is how low, the right is how high. So do you see how it's going up to 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 100, 200, 500, 5 million, 10 million, so on, so on, so on. We're in positive numbers, so it's going toward positive infinity. And remember, you can't actually reach infinity. It's an idea, so we're going to do an open parenthesis. Okay, let's try two more. This one is clearly more like the top problem, number 9. But again, remember with these things, I'm trying to think how I'm going to draw a little note on the side here. So we always have either, well, I'm going to draw that in a second because I have a different thing. I want to show you one more thing. The furthest to the left, this one can go as negative infinity. And remember, I can't ever actually touch negative infinity. Now on this next part though, it goes up to 2, but it's different than the last one. Remember how the last one had an open circle we couldn't actually reach to, so we did an open parenthesis? Well, this one has to be more firm. We can actually touch 2, and that's where we stop. So we are going to do what we call a closed bracket for our closed circle there. And then the next one starts at 2, and it's a closed circle at 2. So I'm going to do a closed bracket at 2, and it goes upward toward positive infinity because it's headed toward those positive numbers. To the right is always positive infinity. To the left would always be negative infinity. So let's put a little note here. You either have a parenthesis or a bracket, one of those two things, and then you have your distance to left, then you have a comma, then you have distance to right, and you either have a parenthesis or a bracket. I don't know if that's helpful to anybody. I've just made that up right now, but hopefully it'll give you a good idea. Remember, you can only have negative infinity. It's not always negative infinity because sometimes you start with a different number, but negative infinity can only go on the left. Positive infinity can only go on the right. I often see people mix those two up. They try to tell me positive infinity is on the left side. You can't ever go toward the left to positive infinity because that just doesn't exist. Negative numbers go toward the left. Okay, let's flip our paper over and we'll do some problems on the back side where we are going to try solving some inequalities. So you're going to solve the following inequalities, graph the solution set, and write the solution in interval notation. So let's start on number 13 by solving this thing. On these sorts of problems, you are always allowed to still separate the two sides if you'd like. And I know that I want to undo multiplying by -5, so I'm going to divide by -5 on both sides here. Now, remember, that should set off warning bells in your mind. Dividing by a negative, we have to do something with the symbol in the middle when we divide both sides by a negative. Remember, if you multiply or divide by a negative number, reverse the symbol. That's written really odd, but we would have x, and instead of less than, we'd have greater than -7. There's my inequality answer. It looks like they want me to write that here. X is greater than -7. Don't write the interval until you have the graph. So put our graph on here. I always just put the number in the center, so -7. What is a number that's lower than -7? It's not -6. If it's -7 degrees out, colder than that would be -8. So you get deeper into the cold numbers. And above that would be -6. I hope you've never experienced those temperatures, but trust me, they are not pleasant. All right, now it says that x is greater than -7. It does not say equal to. So I'm actually going to draw an open circle, and I want to show you that you don't have to draw the circles on the graph. You can draw them floating above. I believe that's how Miss, I don't know if you had her as Miss Olson or Miss Dye, but that's how she usually draws hers, and that's totally fine. And if you would prefer to do that, that's great. We want to go greater than that, so I'm going to shade everything above like this. My interval notation would tell me that to the left, the furthest that my shading goes, is -7. But since it's an open circle, I need an open parenthesis. Then the furthest up I can go is toward positive infinity. Yes, that's a negative number, but eventually we get to 0, then 1, 2, 3, 4, 5, blah, 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 blah. So you can never reach infinity. There will never be a hard bracket next to infinity because you can't reach that. Okay, let's try problem number 14. I'm going to start solving this thing. I'll begin by adding 4 to both sides of my inequality. Then I have 2x is less than or equal to 14. Last step, divide by 2, x. And by the way, I'm dividing by a +2 on both sides, so I do not reverse the symbol. It's still less than or equal to 7. My solution, x less than or equal to 7. My graph, I put 7 in the center. Above that would be 8. Below that would be 6. Now I'm going less than or equal to 7. So I start at 7, and since it can equal 7, I'm shading in there. And I'm going to shade everything that is less than that. And it should look like that. For my interval notation, I know that the furthest left this can go is an arrow pointing toward -infinity. Furthest right is it goes to 7. Now remember, you cannot touch -infinity. We always put soft parentheses on infinity because that's an idea that we can't ever actually reach. Then 7, you can reach that. It's a filled in circle and it was equal to, so we have a hard bracket. 9th graders, you are going to finish this page. Go ahead and try these last 4 problems. Push pause, do your best. I'm going to go over them in just a moment. Hopefully you had a chance to finish those up. Let's start on this one. I subtract 5 from both sides, and I have -4x is less than or equal to 12. Last step, divide by -4, divide by -4. When I do that, when I'm dividing by a negative, I've got to remember that the symbol reverses. It's going to be greater than or equal to -3. So x is greater than or equal to -3. I put my graph with my line having -3 in the middle. Colder than that would be -4 degrees, and then -2 would be up above it. Greater than or equal to -3, I need a closed circle at -3, and I'm shading everything above that. My interval would start at -3 with a hard bracket, and I go toward infinity. Oh no, a fraction! Okay, well, let's figure it out. How do you undo x divided by -3? Well, to undo dividing by -3, I need to multiply by -3, multiply by -3. That is done on both sides, and I have to flip the symbol. So I end up with x being less than, and if I am doing 10 over -9, 10 over -9, oh boy. I don't know why it's not letting me do that, but you can do this on Desmos, or if you did 10 divided by -9. And then you are multiplying by -3, and you can obviously change that into a fraction, fraction to decimal, and then you can go back to an improper fraction and you get 10/3. If you prefer to do this with simplifying fractions, we have 10 over -9, -3 over 1. I can simplify by dividing both of these by -3, and I would get 10 for my numerator, 3 for my denominator. This one might be simpler to put in decimal approximation. So what is 10/3? 3 1/3. Okay, so I know that x is still less than 10/3. And if I put my graph, it's, what did it say? If I put a 3 on here and a 4, and 10/3 is actually 3 1/3, it's gonna be like approximately here. So I'm gonna put my open circle at that spot, and everything less than that's going to be my solution. And remember, that's at 10/3. Kind of a weird one. We're going from -infinity toward the left because the arrow points toward the left, and it goes up to 10/3. Open circle because it did not have an equal to on it. Okay, problem number 17. We have x's on both sides of the equation. Let's get those together first. I'm going to subtract x from both sides. I have 4x plus 68 is greater than or equal to 75. I don't know why I did that in red. Then I can subtract 68 from both sides. And then 75 minus 68 is 7. So 4x equals 7. All right, last step, I can divide by 4. Divide by 4. X, oh boy, do you see how I made that a equal to sign? That should be greater than or equal. So x is greater than or equal to 7/4. We didn't flip the symbol because we didn't multiply or divide by a negative number there. My solution, x is greater than or equal to 7/4. And 7/4 is the decimal 1.75. So I'm going to have this graph, and the dot is going to be between 1 and 2. 1.75 is about right there. That would be 7/4. That is going to be a closed circle at 7/4 because there is an equal to on it. And you are shading everything greater than that. So shade above the circle. My interval notation would tell me that it starts at 7/4 with a closed bracket all the way up to positive infinity because it's pointing toward the right. All right, last problem. Separate the two sides if you'd like. Distribute that -2 to everything inside the parentheses. -2 times x is -2x. -2 times -3 is +6. And that is less than or equal to -7. I can subtract 6 from both sides of this equation. -7 minus 6 would give me -13. I don't know why there's so many negatives here. -2x is less than or equal to -13. And then I can divide both sides by -2. Remember, when you divide by a negative, flip the symbol. Okay, so that becomes x is greater than or equal, and I'll leave this one in decimal form to remind you that that can happen. We got 6.5. My solution, x is greater than or equal to 6.5. My graph, I can put a 6 here, I can put a 7 here, and I know 6.5 is in the middle. That is going to be a closed circle at 6.5, and it says x is greater than that, so we shade everything above the 6.5. My interval would be 6.5 with a closed bracket up to infinity because it heads to the right. All right, let me know if you have any questions on these, and do your best on these practice problems. They should be really similar, and they are expecting you to draw the graph on your paper, and then you are going to talk about what the graph looks like when you type it into Canvas. So be really clear on that and make sure you're showing your work on your paper when you do this homework.